Welcome to my channel, everybody. And today this is the discussion about the asymptotes, rectilinear asymptotes, and with the help of the differential calculus. And what is the rectilinear asymptotes? And now here is the definition. A straight line is said to be a rectilinear asymptotes of an infinite branch of the curve if, as a point P of the curve tends to infinity along the branch, the perpendicular distance of P from that straight line tends to 0. Again I repeat, a straight line is said to be a rectilinear asymptotes of an infinite branches of the curve if, as the point P of the curve tends to infinity along the branch, the perpendicular distance of P from that straight line tends to 0. See the drawing here, then it would be clear about the definition of asymptotes. Now see, y equal to f of x is defined when x tends to a plus, means actually we mean that x tends to x greater than a actually, okay, when it is defined x greater than a. Now see the drawing, and this is x axis and y axis. This is x axis and this is an y axis, okay. And see under that x equal to a, if this is a line x equal to a, let us assume this is defined under x greater than a. So if y equal to curve is that, okay, and let us assume here is a P point and P goes to the infinity when P tends to infinity, and then under some line, let us assume this is actually x equal to a, this line is x equal to a, and this is about a line, let us assume this is y equal to b, okay. If this distance is pt, actually this length is, sorry, enlarge the drawing clearly, see, x axis y axis, and under some line this is here, and this is x equal to a here, a curve y equal to f of x, okay. And under some line, let us assume this is y equal to b, under that a point P, here is a P and this is a T, and this distance and P goes to infinity on the branches, on the branch, and P tends to infinity, then this gap, this is PT, then PT tends to actually this is 0, then this line is called the asymptotes of this curve, okay. This line, then PT, actually PT is equal to, P point here is xy, okay. So this length is this is y, and this height is b, this height is b, so this is b, and this is tends to 0, then this is equal to 0, then b, y equal to b is the asymptotes under this condition. Now it would be clear for the example this, see the calculation here, y is equal to y square minus twice xy plus twice x equal to 0, then we get here y equal to actually minus b plus minus root over b square. B square 4x square b square minus 4ac. This is a, and c is twice x by 2, and we get here x plus minus sorry, and we take a common 4 and 2 are cancelled, then x into, so x minus 2. Therefore this is valid under the condition is 0 to 2. Yes, this is would be a real, this is this is would be a real, except y is real except 0 to 2. So this function is defined except this domain. So see, and we have to trace the drawing here first, then we find the asymptotes in my discussion. See, x equal to 0 and x equal to 2. This is x equal to 0 here, and this is here x equal to 2. And now trace the drawing. Okay, and this is here valid for the curve y equal to x plus actually and root over and x into x minus 2 here, and this is the drawing here x minus under root. Okay, in that interval the function does not exist here, so it is exist except this domain. And let us assume a point P here. This is P and that is xy. Now we have a draw a line. This is, let us assume PT. Now PT is equal to, this length is y, and actually from that, and this is y equal to actually 1. From this we have to show how we can find y equal to 1 is that, see carefully, y and y square minus twice xy plus twice x is equal to 0. Now y square is equal to, take a common twice x and y minus 1 actually, then y minus 1 is equal to y square by twice x. Okay, and x are increased to infinity, so when x tends to infinity, then y minus 1, actually this is 0. Okay, so this line is y minus 1 equals actually, so this length is 1, so this is y minus 1. Okay, so now when x tends to infinity, p tends to infinity, and actually x tends to infinity, it means that, and then we get pt tends to 0 actually, therefore y minus 1 equal to 0, then y equal to 1 is a asymptotes. Is the asymptotes, is the okay, is the asymptotes. So this is the common sense of finding the asymptotes. So I think all of you have better understood the concept of asymptotes. Okay, now we want to introduce some problem. find the asymptotes of the curve x square y x y square plus xy plus y square plus x minus y equal to 0. So student, see the degree of this curve. As we see, this is the same degree and this is the second degree and this is the linear degree. So take a common xy from that. So we get here x minus y, and here is y, x plus y, and here is x minus y. Okay. And now we have to find the asymptotes, and this is the procedure. You see the procedure here. Asymptotes parallel to the x equal to 0. Here the three factors. Is this, and this also. The asymptotes. The asymptotes was parallel to x is equal to 0. Parallel to x is equal to 0 is that if x equal to 0 parallel to x, then the x variable is would be written here and divided by the remaining all this to the other part, and then we get here x plus y by y into x minus y, and also see x minus y by and y into x minus y, and it can be also written by limit x tends to 0 limit x tends to 0 here. Now see, these two factors are cancelled. So after that, y cancel. So that is x plus, if we put the limit x tends to 0, then we get here y by minus y. And see, this is x tends to 0, this is here y tends to, as x tends to infinity, let's see here, if x tends to 0, then y tends to infinity. Okay, so 1 by y is here 0. So this is, and this is the logic. This is the logic. X tends to, if infinity, then we get here as a y equal to 1. If y tends to infinity, then we get x equal to something. Okay, as x tends to 0, then the alternative variable y tends to infinity to the curve. Then x minus 1 equal to 0 here. This is the first asymptotes of this curve. And the second asymptotes parallel to y equal to 0 is y plus, then y would be written here, and see the writing technique of this asymptotes. If y is present here, then the variable y would be a constant like that. So as here x tends to, so this is here y equal to 0. Actually the written technique is here some missing, and this is equal to 0 here, and y tends to infinity, and this is equal to 0 here, and y tends to infinity. So y equal to 0 here, and then x tends to infinity. Then the other variable here is x plus y, and divided by, if we take here y, so other we have x into x minus y, same as x minus y by x into x minus y, and the limit here is y equal to 0 and x tends to infinity here, and this is the 0. So y plus y into, and y be 0 here, so if we put y equal to 0, then we get here limit x tends to infinity, then x by x plus, so if y is 0, 0, x by x square, so x are cancelled, so equal to 0. So C y plus y into 1 plus 0 equal to 0. So y is equal to 0 and that is y equal to 0. Okay? And this is the second asymptote. And the third asymptote, and the is here parallel to that, is parallel to x minus y equal to 0. So that is x minus y and limit x equal to, actually if this 0 then x equal to y, and then y tends to, technique, see that on the left hand side here is x and right hand side is y, so y tends to infinity. On the left hand side here is y equal to 0, so x tends to infinity. Okay, and let us assume this y is subject to x and then x tends to infinity, and here is x is subject to y, then y is infinity. Okay, so like that. Okay, now see the other factor we have are this is a y into x plus y and divided by xy, same as the limit x is equal to y and c, and this is here x minus y by xy, and this is be 0. Okay, see, so this is here x minus y, and apply the rules here, x equal to y plus limit y tends to infinity, see x equal to y, so you replace in place of x in term of y, so 2y square, and this is y square on C, and if x equal to y, put this part, then we get here 0 equal to 0. Okay, so these two are cancelled, so this is 2, so x minus y plus 2 is the third asymptote of the graph. Okay, so I think all of it will get understood for finding the asymptotes. And now okay,